Next, we are going to talk about manipulations on generating functions and how we can obtain generating functions from other generating functions, and what are the relationships between generating functions of two different sequences, etc. And the first observation is quite simple. If f and g are generating functions of, let's say, two sequences a sub k and b sub k, in this case their sum as a generating function corresponds to the sequence where the terms of a sub k and b sub k are added. That's simple, because, well, the coefficients of each term here corresponds to the values in the sequence. So when you add the two functions, the coefficients are all added up, which in turn it corresponds to the addition of these two sequences. When it comes to multiplication, this is a little bit different. For instance, consider two functions, 1 plus x squared, and the other one, let's say, 1 plus 2x plus 3x squared. Now, when you multiply these, well, this goes to all of these terms, so you get 1 plus 2x plus 3x squared plus this one goes to again all of them. You get x plus 2x squared plus 3x to the power 3 plus finally you get x to the power 2, 2 times x to the power 3 plus 3 times x to the power 4. Okay, so arrange them together. The coefficient of x to the power 0 has just this contribution, just 1. Now, x appears here, so 2 of them. Another one here, 3, so that is 3x. Now, how do I obtain this 3? You see, you either get this pair or you get this pair. Okay, so in the first sequence, my first number, A0, and the second number in my second sequence, B1, this one, are multiplied, and then the coefficient here is 1, obviously, and the coefficient here is 1. And the second number in my first sequence, A1, is multiplied by the first number in my second sequence, B0. And then these two products are added up to give me the coefficient of x to power 1. This is simply the expansion of the product of two functions. So the same goes for x to power 2. So I have one here, another one here, another one here. Okay, so that is 3 plus 2 plus 1. I have 6x squared. And to obtain this, I have used either this pair or this pair, or this pair, to obtain x squared terms. Okay, so now these three pairs, these three products, when added up, gives me 6. So it goes on like this, and you look at x to power 3. I have just 2 of them, and they are due to the pairs this and this. So that is A1 and B2 and A2 and B1. You see the subscripts, when you add them up, it gives you the power 3. So that is x, 3 times x to power 3, 2 times x to power 3, so that is 5 times x to power 3, and 3x to power 4. Simple enough. In the general case, you have f of x, g of x, two generating functions, two polynomials. When you multiply them, of course, this a0 by b0 gives you the coefficient of x to 0, and a0 b1 and a1 b0 multiplied and added together will give you the coefficient of x to power 1. Similarly, a0 b2 A1, B1, and A2, B0, multiply them, add them up, that will give you the coefficient of x to 2, and so on. So this we call the convolution, okay? The coefficient of x to power k is in fact equal to the convolution of the sequence ak and bk up to value k. So this is a general rule when we deal with generating functions. In the sequence domain, multiplication corresponds to, convolution in the sequence domain corresponds to multiplication in the generating function domain. So this is useful in a lot of situations. And here at this point, we can do an example. This is a familiar question because we know the answer to this question, but I'm going to show you how you can actually solve this using generating functions. Maybe it's not the easiest way, but this should give you an idea about how this is working. And it will also tie in with the convolution idea. So the question is, how many ways are there to select a team of 2 without order out of 5 candidates? Okay, so we have 5 candidates, 5 people, out of which I would like to form a team of 2. Now, the answer to this, as we know, is 5 choose 2. That's a combination because it's without order. Now, we can construct the generating function as the collection of all possible teams out of 5. Now, we are not constricting the size of the team here. We are just going to list all possible teams as a generating function. The teams consisting of 0 elements or 0 candidates, the teams consisting of 1, the teams consisting of 2, etc. So my generating function is going to represent all those numbers, and I'll just look at the coefficient of x to power 2 to obtain the number of different teams involving 2 people. So how I can do that is every candidate can contribute 0 or 1 times. So remember the coins, the very first example. The coins had unlimited input, so you can use 0 pennies or 1 penny or 2 pennies or 3 pennies and so on. But here, of course, every candidate can be involved in a team either 0 times or just once. So you cannot put one person in a team twice or 3 times. It's simply against the nature of the question. So the generating function of the input of each candidate is 1 plus x. Okay, so 1 corresponds to not putting this person in the team, and x corresponds to putting the person in the team. Okay, and this is for just 5 candidates. Therefore, my generating function is 1 plus x to the power 5. And if you expand this using the binomial theorem, this gives you 5 choose 0 times x to the power 0 plus 5 choose 1 times x to the power 1, and so on up to 5 choose 5 times x to the power 5. So this is the generating function of all possible teams. And this gives me the number of teams with 0 members. So 5 choose 0 is 1. So the number of teams with 0 members is 1. There is no alternative. And this x to the power 1, so this is the number of possible ways to construct teams of 1 out of 5 people. That's 5 choose 1 as expected. And this is the answer we are looking for. 5 choose 2, x to the power 2. So x to the power 2 indicates this coefficient here is the number of ways to construct teams of 2 out of 5 people. Okay, so you get the idea. What if the order is important. Okay, so you want to construct a team of 2, but this time, let's say you have specific positions in the team, so that assignment of different people to different positions changes your selection. So in this case, again, we know this, the answer to this question, that is 5 to power 2. In this case, the generating function is going to be built around the selections, not the people, but the selections. So for the first position, you can choose out of 5 different candidates. So you can make a selection of this person or this person or this person or this person, etc. Okay, so we can repeat this again 0 times or 1 time or 2 times, etc. So the generating function in this case is 5 to 0 plus 5 to 1 times x plus 5 to 2 times x to power 2 and so on. So this, since this is 5x and this is 5x, this is simply 5 to the power n x to the power n and in the infinite sum. So obviously the coefficient of x squared is going to give us 5 to power 2, 25. So this is the number of ways to construct a team of 2 when the order is important. So this also gives you the general rule as 5 to n. If you would like to construct a team of n, the answer would be 5 to power n.